All right, welcome to today's Explainer. We are diving into a genuinely fascinating Google white paper today, put together by Adi Osmani, Shubham Sabu, and Socrates Kartakis. It's titled The New SDLC with Vibe Coding. And let me tell you, this document literally redefines how we need to think about the modern software development lifecycle. If you're building software, if you manage engineering teams, or honestly, even if you just work adjacent to tech, the rules of the game are completely changing right under our feet. And this paper lays out exactly how. Let's just kick things off with a number that should absolutely grab your attention. According to the paper's data from early 2026, 41% of all new code is now AI generated. I mean, just take a second and wrap your head around that scale. Almost half. On top of that, a staggering 85% of professional developers are regularly using AI agents to get their work done. And over half of those are using them daily. So the adoption phase? Yeah, that's essentially over. We are now fully in the execution phase.
So what does this actually mean for us? Well, the biggest shift in software engineering right now isn't a flashy new programming language. It's not some cool new front-end framework or cloud architecture. The fundamental paradigm shift, as the authors perfectly point out, is that the core job of an engineer has moved entirely away from physically typing out code. Instead, it is now all about expressing intent. You express the intent, and then you trust the machines to turn that intent into working, functional software.
Which brings us to Section 1, Vibe Coding versus Engineering, where the authors clarify arguably the most misunderstood buzzword of our time. You see, AI assistance isn't just a simple on or off switch, it's a massive spectrum. On one end, we have vibe coding. This is basically giving into the vibes, right? It's firing off quick prompts, accepting whatever the AI spits back out, doing a minimal review and just asking, hey, does it seem to work? Cool. It's basically the modern equivalent of testing directly in production. And look, it's perfectly fine for a disposable script or a quick prototype. But on the other end, we have what the paper calls agentic engineering. Now, this is disciplined. This is where AI acts as a powerful implementation engine that actually runs inside a strict structure of formal specs, automated tests, CI/CD gates, and real human oversight. Telling your boss you're vibe coding the new billing system? Yeah, that's terrifying. Practicing agentic engineering is how you actually ship securely at scale. So what's the actual dividing line between those two worlds? The paper argues it comes down to one single word: verification. Without rigorous verification, you are just vibe coding, no matter how clever or complex your prompts are. And this verification has two sides to it. First, you need traditional tests to check the deterministic parts, meaning if I put X in, do I absolutely get Y out? But you also need evals to check the non-deterministic parts. You have to ask questions like, did the AI agent take a sensible path to get there? Did it actually use the right tools? Did it meet our overarching quality bar? Okay, moving right along to Section 2, the 1090 rule, where an agent equals the model plus the harness. I honestly think this is the biggest mythbuster in this entire explainer. Think about it. When an AI agent fails to code something right, our very first reflex is usually just to blame the underlying model, right? We just throw up our hands and say, well, guess I'll wait for the next, smarter version to come out. But this paper reveals a super counterintuitive truth. An actively running agent is a combination of the model and its harness. And remarkably, the model itself determines only about 10% of the overall behavior. The other 90%? That is the harness. It's the prompts, the null files, the tool access, the guardrails, the context policies, and the sandboxes that you wrap around that model. And they back this up with some absolutely wild hard data. Look at this first experiment on a public benchmark called Terminal Bench 2.0. An engineering team took a coding agent that was sitting way outside the top 30. By changing only the harness, literally using the exact same underlying model, they skyrocketed its performance into the top 5. No way, right? In another experiment run by LangChain, simply tweaking the prompts, the tools, and the middleware lifted an agent's score by a massive 13.7 points. The takeaway here is crystal clear. When an agent misbehaves, it's almost always a configuration failure, a missing tool, or a vague rule in your harness. It's rarely a fundamental limitation of the model itself. So here is the crucial strategic takeaway for all of us. The harness is your surface area. The behavior you actually experience in your development environment is dominated by the scaffolding that you build, that you own, and that you improve. Your company's durable competitive advantage and intellectual property, it lives right there, in the harness. It definitely doesn't live in whichever shiny new frontier model you just happen to be renting this quarter. Now, if the harness really is 90% of the work, then the skills required to be a great developer are totally shifting. Welcome to Section 3. Context is the new code. Because context engineering is the new core discipline. Instead of trying to trick an AI into writing good code, The paper suggests a much healthier mindset. You need to ask yourself, what would a competent human new hire need to know to actually do this job? You have to explicitly encode that information. The authors categorize this into 6 specific kinds of context you have to supply to the agent: specific instructions, deep domain knowledge, conversational memory, clear examples, access to tools, and strict guardrails. It's pretty simple math. Quality context equals quality code.
But here's the catch. You can't just dump all your company's information into a single prompt. The paper highlights a massive architectural decision we all have to make regarding context management. You have static context, which is information that is always loaded. This is incredibly expensive and slow because every single piece of information, every token is riding along on every single request. It's like renting a massive moving truck every time you go to the grocery store. On the flip side, you have dynamic context. This is information loaded strictly on demand, which makes it highly efficient, cheap, and scalable.
And to make that dynamic context actually work, the paper defines this brilliant concept called agent skills. Think of these as tightly packaged little bundles of procedural knowledge. An agent only loads a specific skill when the immediate task actually calls for it. It's an elegant pattern that allows a broad, generalist AI model to instantly flex into a highly focused specialist, completely avoiding the computational weight of carrying every possible capability at all times.
All right, let's talk money in Section 4, total cost of ownership and the token economy, because ultimately every technical choice we've talked about translates directly into business costs.
Vibe coding is incredibly deceptive here. It feels practically free, right? You pay a flat monthly subscription, toss in a few prompts, zero upfront cost. But it carries a massive, compounding operating tax down the line. You end up burning huge amounts of tokens just fixing unstructured errors, and 6 months later, humans have to step in to untangle an AI-generated spaghetti code mess. In fact, the paper notes that ad hoc prompting can end up costing 3 to 10 times more per feature later on. Agentic engineering totally inverts this. Yes, it absolutely has a high upfront cost to design structured schemas and build rigorous test suites. But in return, you get a consistently low marginal cost per feature for the entire lifespan of that product.
To further control those costs in this new token economy, owning your harness allows you to do something called intelligent model routing. This is super cool. It means you deliberately route the heavy, complex work, stuff like system architecture and initial coding, to the big, expensive frontier models. But you route the simpler, deterministic work, like generating standard tests, monitoring CI pipelines, or just fixing simple typos, to small, incredibly cheap models. You should literally never be paying premium frontier model prices just to fix a missing semicolon.
Now, this white paper isn't entirely wearing rose-colored glasses. Let's get real for a second in Section 5, the 80% problem in amplifying culture.
While so many industry surveys are out there boasting about these massive productivity gains, the authors cite a really sobering study from Metra. They found that experienced developers actually took 19% longer to complete certain tasks when they were using AI. Why? Because the time they saved by not physically typing was entirely eaten up by the much heavier burden of verifying, debugging, and correcting the AI's subtle conceptual errors. AI often solves the first 80% of a problem instantly. But man, that last 20%, the edge cases, the weird integrations, it becomes a tangled mess because the code actually looks perfectly correct at first glance. Because the bottleneck has officially moved from typing over to specification and verification, the role of the developer is effectively splitting into 2 distinct modes. You are either acting as a conductor, working hands-on and in real time within your code editor right alongside an AI assistant. Or you are an orchestrator, working asynchronously, delegating complex tasks to background agents and reviewing the high-level outcomes rather than checking individual keystrokes. And this leads us to what is probably the most critical warning in the entire source document. AI amplifies the engineering culture it lands in. If you drop powerful agentic tooling into a disciplined team, they are going to ship incredible software faster than ever. But if you drop it into a shop with weak tests, vague specs, and a casual review process, you do not get a faster good team. You just get a faster bad team, generating technical debt at a speed no human can possibly ever pay down. The paper concludes with this incredibly powerful summary. Generation is solved. Verification, judgment, and direction are the new craft. The physical act of generating syntax, that's just no longer the hard part of software engineering. Applying critical judgment and effectively directing the system is where your true value actually lies now. Which leaves us with one final vital question to consider as you step back and build the future of your organization. If the model is really only 10% of the equation and your competitive edge, your quality control, and your financial stability all live within the 90% that is the scaffolding, who actually owns your harness? Is it you or is it your vendor? Really think about that as you design your next project. Thanks so much for joining me on this explainer, and as always, keep building smart.